The day I found the jawbone, I was just a kid with dusty shoes and a head full of questions. It was late summer in northern Greece, and I was tagging along with my uncle Nikos, who's a real-life paleontologist. He studies ancient bones and fossils. Basically, he's like a time traveler, but instead of a machine, he uses rocks and dirt. That day, we were near the village of Ravin de la Pluie, where some of the oldest hominid fossils in Europe had been found. I wasn't supposed to touch anything, of course. But then I tripped over a small rock that turned out to be more than just a rock. It was a fossilized piece of jaw, heavy, dark, and with teeth that looked weirdly human. "Uncle!" I shouted, holding it up. He rushed over, squinted at it, and then his eyes went wide. He didn't even speak for a few seconds. "Where did you find this?" he finally asked. "Right there," I pointed. He stared at the ground, then at the fossil, and then said something I'll never forget: "You might have just met someone who lived 9 million years ago." And that was my first encounter with Ouranopithecus macedonensis. But who exactly was this ancient ape with the big teeth and the bigger mystery? That's the story I want to tell you. A missing chapter in our story. Most people know about Neanderthals or Homo erectus. You've probably seen those museum models with hunched backs and serious eyes. But way before them, millions of years earlier, there were apes living in Europe, not Africa. That surprises a lot of people, especially since we always hear that humans came from Africa. Which is mostly true. But the full story is way messy than that. Ouranopithecus lived around 9 to 9.5 million years ago, during a time called the Late Miocene epoch. Back then, the area we now call Greece was warm, kind of forested, with patches of open land. It wasn't exactly jungle, and it wasn't a desert either. Something in between. It had rivers, lakes, scattered trees, and probably big predators too, creatures that could tear through the undergrowth without a second thought. And in this world, somewhere between ape and what we'd later call human, lived Ouranopithecus. But here's the thing: when scientists first found pieces of its skull and jaw, they didn't even realize how important they were. The bones looked odd. They weren't clearly ape, but they also weren't clearly human. It was like someone had taken bits of both and mixed them into a creature we didn't know existed. The jaws were massive, the teeth thick and flat, good for chewing tough food. Some thought it looked like a gorilla. Others said no, this might be one of our ancestors. That argument still goes on today. The name in the dust. Let's talk about the name Ouranopithecus. It's Greek, of course, and it means sky ape. Sounds poetic, right? But it actually comes from Ouranos, which means sky, and Pithecus, which means ape. The name was chosen partly because of where it was found, Greece, and partly because scientists love using Greek and Latin when they name species. Makes everything sound more official. The full name, Ouranopithecus macedonensis, tells us it was found in the region of Macedonia. Not the country, but the historical region in northern Greece. The fossils were first described in the 1970s and 80s by researchers who were just as puzzled then as we are now. I remember asking my uncle, was Ouranopithecus really one of us? Like, our great-great-great, like a million times grandparent? He looked at me and said, maybe. Or maybe it was a cousin we lost touch with. The clues in the skull. What makes this ancient ape so fascinating isn't just how old it is, it's how it looks. The best fossils we have include parts of the skull, jaws, and teeth. No legs or arms yet. No hands or feet. So we don't know exactly how it moved. But the face? Oh, the face says a lot. Ouranopithecus had a large, broad face with massive cheekbones. Its jaw was U-shaped, strong, and deep like a powerful chewing machine. The molars were thick and flat, and the enamel on its teeth was super thick. That suggests it was eating hard, tough foods, maybe nuts, seeds, or fibrous plants. Nothing soft or sugary, that's for sure. Its canine teeth, the ones that stick out like fangs in apes, were smaller than a gorilla's but bigger than a human's. That could mean it didn't need to fight for mates as much as gorillas do. In ape species today, big canines usually mean lots of male-to-male fighting. Smaller ones. Maybe the social system was different. Maybe the males didn't fight much. Or maybe the females had more say. Which would be kind of cool, honestly. Even more interesting, the shape of the skull and face has some similarities to early hominins, the group that includes humans and our direct ancestors. Some scientists look at the eye sockets, the face angle, and the dental features and say, wait a minute, this looks a lot like something that could be on the human side of the tree. The Europe versus Africa debate, here's where things get complicated. For most of history, the idea has been that humans evolved in Africa. And again, that's still mostly true. Homo sapiens, Homo erectus, Australopithecus, those all come from Africa. But around the time Ouranopithecus lived, Africa and Europe weren't as separated as they are now. Sea levels were different. Land bridges appeared and disappeared. Animals and apes could cross back and forth. It's totally possible that early ancestors of humans were living in both continents. Some scientists even think that Ouranopithecus might have been part of a group that led to the hominins in Africa. Like, maybe Ouranopithecus or its descendants crossed into Africa later and gave rise to the line that eventually became us. That would mean Europe played a way bigger role in human origins than we thought. Of course, this idea is controversial. Not everyone agrees. Some researchers say Ouranopithecus was just a weird European ape, not connected to us at all. Others say it's the missing link we've been looking for, the connection between apes and humans, hidden in the rocks of Greece. Either way, it's got people talking. And digging. And arguing. The fossils speak, kind of. There's a quote I once read in my uncle's office that said, "Fossils are whispers from the past." I didn't really get it at first. But now I do. Every bone, every tooth, is like a tiny voice trying to tell us what life was like millions of years ago. Ouranopithecus doesn't have a full skeleton yet. No one's found its arms or legs, so we don't know if it walked upright or on all fours. That's a big deal, because bipedalism, walking on two legs, is one of the key features of humans and our ancestors. Still, even without the legs, the face and teeth give us hints. They whisper things like, I chewed hard food. I didn't have giant fangs. I wasn't just a gorilla. But fossils can only whisper. It's up to us to listen. One jaw, 1,000 questions. That jaw I found wasn't actually a new discovery. I later found out it had already been catalogued, but holding it in my hands made everything real. This wasn't just some dusty museum thing. This was a being. A creature that lived, breathed, ate, and maybe even cared for its family. I still don't know for sure if Ouranopithecus was one of our direct ancestors. Nobody does. But it definitely could be. And even if it wasn't, it lived during a time when the world was changing, when forests were shrinking, apes were adapting, and the story of us was just beginning. That's why I think Ouranopithecus matters. Not just because it might be the one, but because it shows how complex evolution really is. It's not a straight line from ape to human. It's a tangled tree, with branches that twist and turn, cross and vanish. And somewhere on that tree, there's a sturdy little branch from Greece, holding a powerful jaw and a mystery that still makes scientists scratch their heads. But even a few pages can say a lot. That's what my uncle always tells me. After we got back from the dig site near Ravin de la Pluie, he brought out a plaster cast of one of the best preserved Ouranopithecus skulls. It wasn't from our find, ours was just a jaw fragment, but this cast showed the whole upper face. It had a big, heavy brow ridge. The eye sockets were wide and deep. The cheekbones stuck out like a boxer's. It didn't look soft or gentle. It looked like it had survived something. We sat down at his work table, and he pointed to the teeth. "These are the clues," he said. "Flat molars, thick enamel. That tells us this animal was eating hard things. Probably roots, seeds, or tough plants. Maybe even bark." "Yuck," I said. "Why not fruit?" "There probably wasn't enough of it," he said. By this time, the forests were shrinking. The environment was changing. That's when he opened an old book and showed me a faded drawing of the Miocene landscape. There were scattered trees, dry grasslands, a few rivers winding through the hills. It didn't look like a jungle, and it didn't look like the savanna either. It looked in between, like nature hadn't decided what it wanted to be yet. Back in the time of Ouranopithecus, Greece wasn't like it is today with olive trees and white buildings and blue sea. It was wilder, warmer, and full of creatures that don't exist anymore: giant rhinos, saber-toothed cats, massive elephants with straight tusks. It was a different world, and Ouranopithecus had to survive in it. Scientists believe it lived in small groups, maybe families. No one has found evidence of tools or fire or anything like that. Ouranopithecus probably didn't do those things. It wasn't a human yet. But it was smart. Its brain was bigger than a monkey's, smaller than a human's. Just enough to understand its surroundings, remember where food was, and maybe communicate with others in simple ways. Not language like ours, but sounds, gestures, looks. One thing that keeps puzzling researchers is whether Ouranopithecus walked on two legs like us or on all fours like other apes. We don't have leg bones yet, so it's impossible to say for sure. But some believe that, based on how the skull is shaped and how the spine might have connected to the head, it could have walked upright at least sometimes. If that's true, it's huge. Walking on two legs is what separates humans from all other primates. It's the start of our journey. And if Ouranopithecus was doing that in Europe 9 million years ago, it would totally shake up what we think we know. I asked my uncle about that. What if this really was the first bipedal ape? He smiled like he'd heard the question 100 times. Then history might need to be rewritten. The debate isn't just scientific, it's emotional too. A lot of people have grown up learning that Africa is the cradle of humanity. And it is, in so many ways. But science doesn't care about borders or feelings. It cares about evidence. And if the evidence shows that some of our early ancestors or at least close relatives lived in Europe, then that's the truth we have to follow. Not everyone agrees, of course. Some paleontologists say that Ouranopithecus is just a side branch. That it looked a little like a human ancestor but wasn't one. Others believe it's part of the main trunk that led to hominins, our direct ancestors. Then there are those who think it's even closer to us than we realize. In one paper, a group of scientists pointed out that the shape of the palate, the roof of the mouth in Ouranopithecus is similar to that of early hominins in Africa, like Australopithecus. They also noted that its face is more orthognathic, meaning it's flatter, not snout-like, which is another human trait. Those aren't things you find in most apes. But again, without more fossils, it's hard to be sure. A face and some teeth can only tell part of the story. We need arms, legs, pelvis, spine. Those are the bones that reveal how a creature moved, how it lived. One night, we were sitting outside under the stars. My uncle was drinking coffee, and I was staring at the fireflies. I asked him, what if we never find the rest of the skeleton? What if this is all we ever have? He thought about it, then said, then we listen harder to what we've got. Even a whisper can guide you if you pay attention. That stuck with me. Later that week, we visited a museum in Thessaloniki where they had some of the original Ouranopithecus fossils on display. Behind the glass, the fossil jaw looked smaller than I expected. Just a few inches long. But when you realize it's been sitting in the earth for 9 million years, it starts to feel bigger than it is. A woman standing next to me whispered to her son, "That's an ancestor of humans." But the museum sign didn't say that. It just said Ouranopithecus macedonensis, possible hominid. I guess no one wants to say for sure yet. Still, just thinking about it made me feel connected to something ancient. Something that came before pyramids and empires and even fire. A creature who didn't have a name or language but might have passed something on, some gene, some behavior, some spark that eventually led to me standing there, staring at it through the glass. I imagined what it might have seen during its lifetime. Maybe it climbed trees to escape predators. Maybe it watched the sunset over the hills of ancient Greece, not knowing how much the world would change. Maybe it held its baby close, the way humans do now. Even though we can't know its thoughts or its voice, we know it lived. It left a mark. And that alone makes it worth remembering. In the end, Ouranopithecus might turn out to be a cousin, not a grandparent. Or maybe it's a forgotten branch on the tree of life that no one paid attention to until recently. But even if it's not our direct ancestor, it's still part of the story. The story of how apes learn to walk, think, survive, and eventually become us. And maybe, somewhere out there, still buried beneath the dirt and stone of northern Greece, the rest of the skeleton is waiting. Waiting for someone to find it, and listen. Some people think bones are just old and boring. But bones talk. Not with words, obviously, but with shape, size, and scars left behind by muscles and time. And when scientists gather around a fossil like Ouranopithecus, it's like watching a detective team trying to solve a mystery that's millions of years old without witnesses, without photographs, and without a confession. After we visited the museum in Thessaloniki, I kept thinking about what my uncle had said, that even a whisper from the past can guide you. And the more I listened to what Ouranopithecus was whispering, the more complicated things seemed. The first question that stuck in my head was, how do we even know if this ape was part of our family? So I asked my uncle again, this time more directly. Why don't scientists just agree on whether Ouranopithecus is part of the human line? He put down his magnifying glass and sighed. Because evolution isn't a straight line. It's a messy tree. And Ouranopithecus could be a branch, or a trunk, or a twig. That's when he pulled out a diagram, a big one, rolled up like an old treasure map. When he spread it across the table, it showed what looked like a tree with lots of branches. But instead of leaves, there were names: Australopithecus, Ardipithecus, Homo habilis, Sahelanthropus, Gorilla, Pan, and so on. And there, off to the side but still connected, was Ouranopithecus macedonensis. He pointed at it and said, "This one's tricky. Some think it's on the line that leads to gorillas. Others think it's closer to humans. And a few even believe it could be the common ancestor of both." That was wild to think about, one ancient ape that could be the source of both gorillas and humans. I pictured a family reunion where the cousins split into totally different worlds, one becoming a chest-beating forest giant, the other turning into us toolmakers, astronauts, kids with phones in their pockets. But how could one set of bones cause so much disagreement? Well, part of the problem is that we don't have enough bones. All the fossils of Ouranopithecus that have been found so far come from a handful of places in northern Greece, mainly around the areas of Nikithi and Ravindalaplai. And most of those are jaws, teeth, and parts of the skull. Important, yes. But not enough to draw a full picture. The best known specimen is a male skull, broken but still incredibly revealing. It shows a wide face with a heavy brow and a U-shaped dental arcade. The molars are huge, flat, and built for grinding. That tells us something about diet, sure, but it also suggests this creature was adapted for a life that required strength, maybe chewing through hard foods in a dry environment. Now, if you compare that skull to modern apes, it's not an exact match. Gorillas, for example, have way bigger canines and more forward-facing jaws. Chimps have different dental patterns. And early humans like Australopithecus afarensis, the species Lucy belonged to, have smaller faces, rounder skulls, and different jaw shapes. So Ouranopithecus stands somewhere in between. Not fully ape. Not fully human. Just, something. And that something has caused decades of debate. Some scientists, like Elwyn Simons and David Begun, argued that Ouranopithecus has enough human-like features to be considered a potential hominin, meaning part of the group that includes humans and our direct ancestors. They point to the thick enamel, reduced canines, and the shape of the face as evidence. Others, like Tim White and his team, are more skeptical. They think Ouranopithecus was probably just another European ape, not closely related to us. Their argument? That similar traits can evolve in unrelated species, something called convergent evolution. Just because it looks a bit like a human ancestor doesn't mean it is one. It's kind of like how dolphins and sharks both have streamlined bodies and fins, but one's a mammal, and the other's a fish. Same solution, different history. So, with Ouranopithecus, the question is, are the similarities with humans real family traits, or just a coincidence? I remember standing by my uncle's desk as he opened a digital scan of the fossil on his computer. He zoomed in on the molars, slowly rotating the 3D model. "You see that?" he said. "That's thick enamel. Humans have it too. It helps us eat a variety of foods. Gorillas and chimps don't need it as much. They stick to softer stuff most of the time." He zoomed out and pointed to the face. "And this, look how flat the face is. Not snout-like. That's another clue. It's like looking at a puzzle where half the pieces are missing, but you still recognize the picture." But even he admitted that without leg bones or a pelvis, we couldn't know how Ouranopithecus moved. And without movement, it's hard to say how close it really was to humans. After all, bipedalism, walking upright, is the one thing all hominins have in common. Some of his colleagues in Athens believe that Ouranopithecus might have had adaptations for upright walking. They point to the base of the skull and how the head might have balanced on the spine. But without more fossils, it's speculation. Educated speculation, yes. But still speculation. And then there's the big question, why was Ouranopithecus in Europe in the first place? If humans came from Africa, what was an almost human-like ape doing in Greece? That's where things get even more interesting. Back in the Miocene, Europe and Africa weren't as separate as they are now. Sea levels were lower. Land bridges existed. Apes could migrate between continents. In fact, Some scientists believe that Europe was a major center for ape evolution at the time. There were other European apes too, like Dryopithecus, Ouranopithecus, and Hispanopithecus. Each one lived at slightly different times and in slightly different environments, but all of them show a mix of ape and human-like features. Some experts think the ancestors of modern apes and humans evolved in Europe and later moved back into Africa. Others believe it was the opposite, that early apes came from Africa, spread into Europe, and Ouranopithecus was just one of their descendants. It's like trying to follow footprints that crisscross in the mud, some going north, some south, and some disappearing altogether. As I listened to my uncle talk about all these possibilities, I realized that Ouranopithecus wasn't just a mystery, it was a key. A key that could open up a forgotten chapter of our origin story. But the lock was rusty. And the rest of the key, its body, its limbs, its world, was still buried underground. That night, I lay in bed thinking about what it would have been like to see one in the wild. Would it have stared back with curious eyes? Would it have run away, or stayed still? Could I have looked at it and seen a piece of myself? Maybe that's what makes Ouranopithecus so important. Not because it proves anything, but because it asks something. Where do we come from? Who came before us? And what does it mean to be human? The answers might be hiding in the bones. Or in the silence between the bones. Or maybe, one day, we'll find a fossil so complete that the whispers finally turn into a clear voice. Until then, the debate continues. The tree of life sways in the wind. And somewhere in northern Greece, the rocks still hold their secrets, waiting for someone, maybe even another kid like me, to pick one up and hear a voice from 9 million years ago. The sun was setting over the hills near Nakiti when my uncle said something that stuck with me. Imagine, he whispered, brushing dirt off a stone, what the world looked like when Ouranopithecus walked here. No roads, no villages, no electricity. Just wind, trees, and the sound of footsteps that left no trace. That's what I kept thinking about, the footsteps. Because for all the mystery surrounding Ouranopithecus, whether it was our ancestor or just a distant cousin, the biggest question might be how it moved. Did it walk like a chimpanzee, using its knuckles and swinging from trees? Or did it stand upright, even if only sometimes, the way we do? It's a question scientists still don't have a final answer to. But they've spent years examining what little evidence we have, comparing the bones of Ouranopithecus with apes and early humans, looking for even the smallest clue. So far, there's been no arm bones, no legs, no pelvis, nothing that directly shows us how it moved. But there are hints. Whispers in the shape of its skull, in the angles of its face, in the way its jaw was positioned. When you walk upright, your head has to sit differently on your spine than when you move on all fours. In humans, the hole where the spine connects to the skull, the foramen magnum, is located underneath the skull, because our heads sit on top of our vertical bodies. In apes, it's further back, because they lean forward. Some researchers believe the placement of this opening in Ouranopithecus suggests it held its head more like a bipt. But without a full skull or spine, it's hard to say for sure. One fossil fragment might hint at something, but in science, might isn't enough. Even so, the idea that Ouranopithecus could have walked upright even part of the time is thrilling. Because bipedalism is the trait that sets our lineage apart. Once an ape starts walking on two legs, everything begins to change: the way it eats, carries food, watches for danger, even how it interacts with others. Walking upright freed our hands to do other things: make tools, carry babies, throw objects, and eventually, wave hello. If Ouranopithecus was experimenting with bipedalism, That puts it right near the fork in the road where apes went one way, and humans went another. But let's not get too far ahead of ourselves. Before we even talk about walking, we need to understand the world Ouranopithecus lived in. Because evolution doesn't happen in a vacuum, it happens in a landscape. And 9 million years ago, that landscape was starting to change. During the late Miocene, Europe was undergoing a dramatic environmental shift. Forests, once thick and green, were slowly shrinking. The climate was drying. Rainfall was less predictable. Grassy plains and open woodlands began replacing the dense canopies apes had relied on for food and shelter. Ouranopithecus lived right in the middle of this transformation. And that tells us something about its adaptability. Unlike tree-dwelling apes that needed thick forests, Ouranopithecus might have been able to survive in a more open environment. That's why its thick enameled molars matter, because they suggest it was eating tough, gritty plants, not soft fruit. That change in diet is a big clue. It suggests not only different food but different behavior. Maybe Ouranopithecus spent more time on the ground, foraging, moving between scattered trees instead of swinging above them. In Africa, around the same time, other apes were dealing with similar changes. Forests were breaking up there too. And it's in those African landscapes that we eventually see the rise of hominins like Sahelanthropus jotensis, Ouranopithecus, and Ardipithecus ramidus, all species that show signs of bipedalism. What's fascinating is how similar some of those fossils are to Ouranopithecus. Take Sahelanthropus, for example. It lived around 7 million years ago in Chad. Its skull is more complete than Ouranopithecus's, and it shows a flat face, small canines, and possibly upright posture. Sound familiar? Now imagine Ouranopithecus as its slightly older European cousin, maybe even an ancestor. If that's true, then our story might have begun not in Africa, but in southern Europe, with a creature whose bones were buried in Greek soil. But that's still a big if. The trail from Ouranopithecus to modern humans isn't straight. It's more like a web crisscrossing species, lost relatives, failed branches. It's possible that Ouranopithecus had descendants who migrated into Africa before evolving into early hominins. Or maybe its kind died out, replaced by other apes better suited to the changing world. We don't know. Not yet. But here's something we do know: Ouranopithecus wasn't alone. It lived in a world full of other remarkable creatures, some of them relatives, some of them just neighbors. Fossils from the same regions in Greece show animals like Hipparion, a three-toed horse Machairodus, a saber-toothed cat, ancient elephants, some the size of buses, antelope, giraffes, even early pigs. These animals tell us about the environment, mixed woodland and grassland, with seasonal changes and lots of different habitats. That's important, because it suggests Ouranopithecus wasn't locked into one way of living. It had to adapt. And adaptation is the heart of evolution. One theory that excites a lot of scientists is that the pressures of this changing landscape, less fruit, more open ground, more predators, may have forced early apes to change how they moved. Standing upright, even occasionally, would have helped them see over tall grass, carry food or infants, and escape danger faster. So maybe Ouranopithecus didn't walk like a human. Maybe it walked like something in between, still climbing, still using its arms a lot, but experimenting with the idea of standing up. We call that a facultative biped, an animal that walks on two legs sometimes, but not always. Kind of like how chimpanzees can walk on two legs for a few steps if they need to, but mostly use all fours. If Ouranopithecus was a facultative biped, that would put it ahead of most apes of its time. It would mean it was already partway down the road that would eventually lead to hominins. I once asked my uncle if we'd ever find a complete skeleton of Ouranopithecus. He shrugged, like always, but then said, "You never know. The earth hides what it wants to hide. But it also gives up secrets when it's ready." He told me about the famous Lucy skeleton, how it was found in Ethiopia almost by accident. The team wasn't even expecting to find much that day. But one bone led to another, and soon they had the most complete early hominin ever discovered. Maybe Ouranopithecus is waiting for us the same way. Maybe there's a hillside somewhere in Greece, holding bones that will change everything. Until then, we follow the clues we have. A thick jaw. Heavy molars. A flat face. A possible bipt. A creature that stood on the edge of the human story, just before the curtain lifted. And every time I walk those dry hills, every time I see the olive trees and feel the crunch of soil under my boots, I imagine those shadows walking, climbing, foraging in a world now lost. They left no footprints. But they left a trace. And we're still following it.